Hey guys, today we're talking about dilations. Dilation is a stretch or a shrink of a figure. It's the image created that's similar to the original figure, but it's been reproduced by a scale factor, meaning it's either gotten bigger or smaller, but has still maintained the same shape. So, for example, if a triangle has vertices A, B, and C respectively, they want us to find the coordinates of the triangle after dilating it with a scale factor of 4. So the first step would be to multiply every single coordinate by 4. So the x coordinate would be multiplied by 4 and the y respectively. So let's multiply each vertex by 4. When we do so, 0 times 4 and 4 times 0 are still the same thing. So we get 0 for A. So this would be A's image. B, however, would be a little different. 8 would become 32, while 0 would stay 0. So this would be B's image. 3 times 4 is 12, and negative 2 times 4 would be negative 8. So this would be C's image. So the new coordinates after the dilation would be the following: A's image, B's image, and C's image. Okay, so they want us to dilate the figure using the following algorithm. Every x is going to be multiplied by 3, while the y is just going to stay the same. So go ahead and pause the video and see if you can do this one on your own. You're multiplying all the x coordinates by 3, but leaving y the same. Okay, I'm going to show you how I would do it. So if you were doing this one, you would multiply the 1, 1 by 3. So the 1, 1 would become 3, 1. So we have a point right here. The 3, 1 would be 9, 1. So we'd go to 9 and up 1. The 3, negative 3 would become 9, negative 3. So we would be at 9, but at negative 3. And the 1, negative 3 would become 3, negative 3. So this would be the shape that we would see. And we would draw in our lines. And if they had points, we'd probably call them an image. Oops, I accidentally clicked. So it became a little crazy. Okay, so that would be our shape right there. So if you look here, if we take this shape, notice that all of the x-axis has gotten bigger by 3. It's 3 times its original, while the y stayed the same length. Okay, let's look at this one. Dilate the figure this time where the y changes by 3. Go ahead and try it, and I'll be back in just a second to show you the answers. All right, so negative 6, 2 would become negative 6, 6. So you're at negative 6, and we would go up 6. This one would become negative 1, 6. This one would become negative 6, negative 3. And this one would become negative 1, negative 3. So when we fill in our shape, it is getting longer, or I guess taller, on the y-axis. Okay, let's look at another one. What if both of them change? So now we need to restructure this as a 2 times every x and 3 times every y. So this one would become negative 4, 9, so negative 4 but up 9. This one would become a 6 and a 9, so over 6 and up 9. This one would become a negative 4 and a negative 3, so back 4, down 3. And this one would become a 6 and a negative 3, so over 6 and down 3. And then we of course draw our lines, and that right there is the dilation of 2 times x and y times 3. Okay, so let's look at another one. What if they dilate it using a scale factor of 2? Graph the triangle and its image, and then come up with the algorithm for me. Okay, I'll be back in just a second to show you the answer. All right, so if you graphed it, this is what it should look like. All right, the structure is changing because the side lengths are getting bigger and this side length has gotten bigger. Okay, all of the sides are getting bigger. So this is a stretch, okay? It's a dilation of 2, so it should be getting bigger, which means that our algorithm, whoops, I've still got it on a line there. Our algorithm should be multiplying the 2 and the x's. Okay. Okay, try this one. What if we have a scale factor of 1/2? If multiplying it by a whole number gives you a larger shape, what do you think is going to happen to this one? Go ahead and try it, and I'll be back in just a second to show you the answer. Okay, so dilating it by 1/2 is going to take a bigger shape and make it smaller. So this would be an algorithm of multiplying both by a 1/2. So taking A and multiplying it by 1/2 would now give you A's image, because 4, 5 would become 2 and 2.5. Oops, I put my image in the wrong spot. Okay, B, which is, if we look here, 4, 8. So this is 8, 5. It would become 4, 2.5. So this is B's image. C is at 4, down 1, 2, 3, 4, 5, 6. So it would become 2, 3. And 8, 6 would become 4, 3. So this would be D's image. And that's all I've got for you today. I'll see you next time.